Good day, everyone. Today we will be discussing hypothesis testing. Specifically, we will be testing the hypothesis on a specific problem. So, that problem for today is emission of nitrous oxide. An LTFRB report reveals that a certain model of car has an average emission of 1.55 grams of nitrous oxide per mile, and the standard deviation for the recorded emissions is zero point 0.4 gram. The car manufacturer claims that they have increased the fuel efficiency of the model, thus reducing the average emission of nitrous oxide. A random sample of 50 cars was tested, and the average emission of this sample is 1.35 grams. Use zero point zero 5 significance level. So, in hypothesis testing, we will follow a certain process. So, the first step in that process is to identify the given or identify the problem. So, our mu is 1.55 grams, our standard deviation is zero point 0.4 gram, our sample size is 50 cars, our x bar is 1.35 grams, and our alpha is zero point zero 0.05. Given that, the next step is to state the hypothesis. So first is our null hypothesis. So this is the statement of equality. This would be increasing the fuel efficiency of the model did not reduce the average emission of nitrous oxide, or mathematically, mu is equal to 1.55. Our alternative hypothesis naman is increasing the fuel efficiency of the model reduced the average emission of nitrous oxide, or mathematically, mu is less than 1.55 since it reduced. And this will also be our claim. Next step is to find the critical value. Since our level of significance is zero point zero 0.05 and since it is a one-tailed test, given our alternative hypothesis being less than, we will use the value 1.645 or negative 1.645 since it is less than. Our next step is to compute for the test statistic. Our formula to be used is presented in the screen. This is the formula we will be using since the standard deviation is known or is given already, and n is greater than 30. So after inputting all the values, our test statistic would be negative 3.54. After that, it is time to make a decision. Since negative 3.54 is less than negative 1.645, we reject the null hypothesis since it lies on the left side of the graph. And after that, we make our conclusion. So since the claim is our alternative hypothesis, the conclusion would be there is enough evidence to support the claim that increasing the fuel efficiency of the car model reduced the average nitrous oxide emissions. Now it's your turn. Presented in the screen is a problem, and I want you to try to solve it.